So, solution stoichiometry. Molarity, we've learned, can be used to convert between amount of reactants in moles and liters of solution. And so we can use this in stoichiometry problems. Now, what was our mantra for stoichiometry? Grams to moles to moles to grams, right? So this is a tweak on that. What we had before was grams to moles to moles to grams. The important part is in the middle. All stoichiometry will have moles to moles in the middle. What comes before and after can vary. And that's why learning dimensional analysis and the basic idea of stoichiometry allows you to do almost a zillion different kinds of problems by learning one process instead of learning multiple processes for specific situations. So we already learned how to do grams to moles to moles to grams. Now we're just going to mix it up a little. We can start with a volume of a solution of a known concentration. If we know the volume and we know the concentration, we can calculate the moles. We're just going to use the concentration, the molarity, instead of the molar mass as our conversion factor. And from moles of this product, we can go to volume of a known concentration. Or you could start with grams, go through and end up with volume, or start with volume and end up with grams. You get the idea? Let's do an example. Common antacid contains magnesium hydroxide, which reacts with stomach acid to form water and magnesium chloride solution. As a government chemist testing commercial antacids, you use 0.10 molar HCl to simulate the acid concentration in the stomach. How many liters of stomach acid react with a tablet containing 0.10 grams of magnesium hydroxide? Is the class snowballing on us? Yeah, it is. Now we need to take these compound names and write formulas from them, and then we need to take those and write a balanced chemical equation, and we're going to need molar mass, and we're going to need to use the molarity, and it's all wrapped up in this one problem. We need a chemical reaction for this. So magnesium hydroxide reacts with stomach acid. And it says we're using HCl to simulate the acid in the stomach. Stomach acid is mostly HCl, but this is telling us to use HCl. So I'm going to write my equation up here on the top because I have to conserve some space. What's the formula for magnesium hydroxide? MgOH2. Magnesium forms a +2 ion. Hydroxide is OH -1, so we need 2 of them. So that's going to react with HCl. I'm just going to leave a little space there in case I need a coefficient. To form water and magnesium chloride solution. Well, water's H2O. What's the formula for magnesium chloride? MgCl2. Again, +2 charge on the magnesium, -1 charge on the chloride. Okay, if you're not getting how we're getting these formulas, we need to talk because you need to get up to speed on this. Is this equation balanced? No. What's one of the elements that's not balanced? The oxygen, and another one? Hydrogen, and chlorine. When I look at this, I see the chlorine as the easiest thing to start with. Here I've got 1 chlorine, here I've got 2. I'm going to put a 2 in here, 2 HCl. Now I'm going to look at this, and there's H's all over the place. So here's O's. There's 2 O's in there, and there's only 1 over here. So I'll put a 2 over here. And then if we're lucky, that'll take care of all the H's. Here on the left, we have 2 H's and 2 H's. That's a total of 4, and 4 on the right. Okay. So there's our balanced chemical equation. Now we're ready to actually start doing stoichiometry. So there's some numbers in the problem. We can use this equation to help us organize those numbers. So here it says 0.10 molar HCl. So I'm going to write this concentration under HCl. So 0.10, and I'm going to write moles per liter instead of capital M, so I don't forget that it actually means moles per liter. And then this other number, 10 grams magnesium hydroxide. So I'm going to write that under, no, not 10 grams, 0.10. I'm going to write that under magnesium hydroxide. Concise way of taking all those words and putting it in a form where we can see what we're doing. And then, what is the question? How many liters of stomach acid? Which one of these is the stomach acid? It's the HCl. So our question, I'll put that in orange so it'll show up on the blue. Question mark, liters. That's what we're trying to find. We always need to figure out where we're going, and we also need to know what we're starting from. So in stoichiometry, we started with one compound and went to another compound. The question is being asked about this compound. We have a number associated with this compound. This is what we're going to start with. So let's write out our path. We're going to start with grams of magnesium hydroxide. And we want to end up with liters of HCl. We always have to go to moles in the middle. We'll find when we do gas laws that we can do even more crazy things on the ends. Always moles in the middle. So grams, we're going to have to go to moles of magnesium hydroxide, and then moles of HCl, and liters of HCl. Any questions about that? From here, we follow our pattern of dimensional analysis to write out the whole big equation with the units. So I've got 0.10 grams of this guy times, we're going to have moles of that guy on top, times moles of HCl on top. We're just following our path. And here we want to get to liters of HCl. So let's stick the numbers in. I'm sorry, not numbers yet. We didn't finish the units. Now we got all the units in. Well, that middle one is always the easiest. It comes from this equation. There's no number in front of magnesium hydroxide. That means that's a 1, because chemists don't like the number 1. And then in front of HCl, we have a coefficient of 2, so we put a 2 in here. Because we need 2 moles of HCl for every mole of magnesium hydroxide. This guy over here, liters per mole. Well, that is this molarity just upside down, right? This is a conversion factor between moles and liters. So we're going to have 1 liter on top. Oops, come back to me here. And 0.10 moles on the bottom. Oh, wasn't thinking here. Where do we get this guy? Molar mass, periodic table. C, magnesium, 24. Is that 3,5? Yeah. 1 of those. 2 oxygens. 2 hydrogens. 58.366. So that goes in over here. 58.366. Now we just go left to right, 0.1 divided by 58.366 times 2 divided by 0.1 equals, how many sig figs? 2. 0.034 liters of stomach acid. Any questions? This requires practice. The homework assignments I'm giving you are the minimum that you should do. There's a lot more problems in your book, and all the blue numbered ones have answers in the back, so you can use those for practice if you need more practice. Is this the same section? No, it's a new one.